Okie dokie. So here on this problem, it's asking us to solve or find the quotient and the remainder by using synthetic division. Now, synthetic division and long division, they work completely different, but they still work out to be giving you the same exact answer. They still give you the same quotient and the same remainder. It's one of the cool things about synthetic division. You're actually not dividing anything. You're not doing any traditional long division, which is great. So how we set up synthetic division. This process goes every single time. You set up a little box or a little corner. I mean, this is just what I like to do. Some teachers do it a little differently. You're going to have some numbers up at the top here. And you're going to draw out a little line. Okay, and you're going to have some numbers down here, some numbers right up here. All right, so let's actually kind of fill in the missing gaps. Well, step one, very first thing you want to do. Take your divisor, set your d of x equal to 0, and solve for x. Okay, so here, our divisor is x plus 2. So we're going to take x plus 2, set that equal to 0, solve for x. So here, we would have x plus 2 equals 0, meaning that your x value would be a negative 2. Now, why on earth do we do that? Well, guess what? The negative 2 is what's going to go in this little corner right here. Okay, so we're starting to fill in all the little pieces. Now, to figure out what numbers go on the top here, these numbers up at the top, they come from your polynomial, specifically the coefficients of the polynomial. All right? So we have an x cubed, we have an x squared, but wait a second, we don't have an x. See, that's what I told you on the last video. Missing pieces. We still have to fill in the missing gaps. And then we have the negative 4. So the coefficient of the x cubed term, well, this number that's right on the outside here, that's an understood 1. Well, that 1 is going to go right there. The coefficient on the x squared term, well, that's a negative 3. Since we don't have a plain old x term, that's going to be a 0 for a coefficient, because if you don't have an x term, that's an understood 0 for a coefficient. And then we have the negative 4. So this is coming from the x cubed term. This is coming from the x squared term. This is coming from the x term that we don't see. And this is the constant, the negative 4. And they all come from this polynomial right up here. Now, once you set up your top numbers, always, like I said, this is a same process every single time. Drop your first term, your first number. All right? Now, here's where it starts getting a little fun. You multiply. Negative 2 times 1. Negative 2. Add them together. So a negative 3 minus 2, well, that would be a negative 5. Repeat the process. Negative 2 times negative 5, well, that would be a positive 10. 0 plus 10, positive 10. Negative 2 times 10 would be a negative 20. Negative 4 minus 20, well, that gets you a minus 24. All right? We got all the hard part done now. Now, this is just what I like to do. The last number that you get in synthetic division, I like to section that off because that's my remainder. Negative 24, that's my remainder. Now, the quotient comes from these guys right here, and these three guys. Now, how you set up the quotient? Remember this. The quotient is always going to start off with the largest exponent that is 1 less than what you started off originally. See, here we started off with an x cubed term. Our quotient is now going to have an x squared term. Well, this right here is the coefficient of that x squared term. So this would be a 1x squared, and then go on down the list. Minus 5x plus 10, with the remainder of negative 24. Clean it up a little bit. Well, 1x squared, well, that's the same thing as x squared. minus 5x plus 10. Remainder of negative 24. And that would be your answer right here. Basically, relating this back to long division. The quotient was the stuff that was on top of the house. The remainder is what you got at the very bottom, at the very end. All right. Now, like I said, synthetic division, this process works every single time. And it's the same process every single time. Drop your first term, multiply, add. Multiply, add. Multiply, add. Multiplying, add, multiplying, add, multiplying, add. That's synthetic division in a nutshell right there. All right. Now, does it matter which one you choose? No, because guess what? They still end up with the same answer. That's the beautiful thing about it. It's a lot less work to do the same exact thing.